Okay, I wanted to give you guys an example of how I use the railroad tracks technique because it's really hard to explain and it would just be easier to make a video. So that's what I did. So let's say that I have like 32.7 grams of, I don't know, carbon. And actually, you know what I'm going to do? I'm going to zoom in a little bit more and work with it then. So I have 32.7 grams of carbon. Let's say I want to find out, I don't know, how many moles of carbon that I have. And if I give you guys that I have, I don't know, 2.3 liters, then what my molarity would be. Okay? So I like to think of this all as a simple conversion problem where we are trying to convert to molarity, which is moles per liter. Okay, what are we given first though? We're given grams. All right, well, how do we get from grams to moles? Well, the first thing we have to do is we have to understand how this whole technique works. And like I said, it's basically a giant conversion thing. And converting something is basically just multiplying a bunch of fractions and getting labels to cancel. And the way to get something to cancel in the form of fractions is to have one in the numerator and one in the denominator, and then they cancel when you multiply them. Okay, so that means that if I have grams in the numerator, then I need grams in the denominator, but I want moles in the numerator. So I need a ratio that relates grams to moles. Well, I know that there are 12.01 grams of carbon for every 1 mole of carbon. Okay, and see what'll happen is my grams of carbon cancel. So the next thing I want to do is I want to get to moles per liter. Well, there's nothing that says, oh, you have to have such and so moles of carbon for every liter. No, we're going to use just this flat rate that we've been given. That we were given liters. That's what I'm trying to say, is we were given liters in the problem. So I want liters to be in the denominator. So we'll put liters below the line, 2.3 liters. Okay, now what you do, multiply across the top, multiply across the bottom, divide the top by the bottom. Okay, multiplying across the top, I have 32.7 times 1 times 1. So that would be 32.7. And then make sure I carry my label across too. So I have 32.7 moles of carbon. Now I'm going to go across the bottom. I have 12.01 times 2.3. And that's 27.63623. Yeah. But that's, I have not rounded at all yet, because I'll do that at the end. Whenever you're doing a problem, don't round until the end. Okay, and now it's my label. My label is liters. Okay, divide the top by the bottom. And that gives me 1.183796112 for my molarity, because I have moles on top of liters. Now I go back and look at my sig figs. I have 3 sig figs here, 2 sig figs here, and we're assume that your conversion factors are perfect, with the exception of values that you've been given, like how we were given that we have 2.3 liters. But stuff like 1 mole of carbon is 12.01 grams of carbon. Just assume that's perfect. That doesn't affect your sig figs. But either way, we only have 2 sig figs for this problem, so our answer would be 2.2. I must have laid my hand on the 2.2 molar solution of carbon in water. Okay, so that is the ladder method, or ladder. You can call it ladder, most people call it train tracks.